Would you agree with the following three questions? That most systems sold today have PSC, permanent split capacitor induction motors. That most homeowners do not run that fan continuously because it makes too much noise and costs too much money to run on a continuous basis. That running the fan continuously would increase the effectiveness of indoor air quality products and help destratify the home. What is destratifying? That's one of those fancy words that nobody really knows what it means. Stratification is when there's no air movement in a home and the hot air in the home goes up and the cool air in the home goes down. And this can even happen room to room depending on the heights of ceilings in different rooms. So basically, whenever the HVAC system is off, the home becomes uncomfortable because the air starts to move around. We can solve that issue by running the fan continuously. But no one wants to run a PSC motor continuously because it makes too much noise. Many consumers have high-dollar indoor air quality items, high-efficiency filters and UV lights, yet they don't run their fan continuously because it's too noisy. In the United States, the average run time for a heating and cooling air conditioning system is around 3,500 hours. There's around 8,700 hours in a year. If you do the math, you'll find that there's over 5,000 hours of constant fan operation that's not being utilized in the typical home due to the fact that the PSC motor is too noisy and costs too much money. So, do you think that your customer would be interested in a motor that uses less energy, optimizes all of their IAQ products, making their home more comfortable, and reduces constant fan noise? Evergreen's been designed specifically to replace inefficient PSC motors. The Evergreen ECM is 80% electrically efficient versus 60% electrically efficient PSC motors. It's also been optimized to provide a quieter, constant fan and provide better airflow than the PSC motor when static pressure goes up in the system, using proven constant torque technology. This chart will help us explain how constant torque technology works in the Evergreen motor. At the bottom of the chart, we see a graph showing static pressure. This represents the total external static pressure of the HVAC system. On the left, we see CFM. If we go down to the bottom and we look at about 0.5 total external static pressure and follow that up, we see that it meets the PSC curve at around 1400 CFM, and it meets the Evergreen curve at around 1530 CFM. So the Evergreen, same horsepower, same speed, is already making more airflow. If we take that up to 0.8 external static pressure, we see that the PSC motor is making around 1130 CFM and the Evergreen motor is making close to 1300 CFM. So anywhere along the motor curve, when static pressure goes up, the Evergreen motor is going to be making more airflow. And if you look real closely at both of those circles on the Evergreen line, we're actually doing it for less wattage than the PSC motor, even at 0.8 static pressure. So what are our opportunities with the Evergreen motor? Obviously, if an existing PSC motor fails, that's a great opportunity to upgrade the customer with Evergreen. But why not offer customers that have working existing PSC motors the option to upgrade to Evergreen now and get the benefit of quiet constant fan, energy efficiency, and improved airflow with their existing system? And if you're selling indoor air quality items or zoning systems, the Evergreen's a perfect match for those systems. Something else to keep in mind is, why did the customer choose a system that has a PSC motor in it when ECM technology has been around for 20 years? Well, keep in mind that many consumers didn't have a choice with the product that's in their home. Whether they built the home and didn't have many choices in the construction process, or whether they bought a home that somebody was selling where the realtor told them, if you put a new system in, it'll help sell the home. And if you're selling a home, what are you going to put in? You're going to put in the cheapest product you can buy, so the new home buyer ends up with a cheaper product than something they may have purchased on their own. So many consumers didn't have a choice in the product they have. Some did have a choice, and they made the choice that economically made sense for them at the time. Now with Evergreen, they can upgrade their system without having to wait until that system dies to get today's greatest technology. Now let's talk a little bit more about the energy efficiency of the motor. We see here a chart with a PSC motor and an Evergreen motor. both installed in the same system, running at cooling airflow, heating airflow, and constant fan airflow. And looking at the red numbers on the far right, we see that the Evergreen beat the PSC in cooling airflow by 90 watts per hour, beat the PSC in heating airflow by 145 watts per hour, and in constant fan beat the PSC motor by a whopping 364 watts per hour. And that's even assuming that this furnace with the PSC motor was running constant fan using heat speed. Many older furnaces for constant fan use the cooling speed. So how do these numbers come out? Where did these numbers come from? Well, ECM motors are 80% electrically efficient. PSC motors are 60% electrically efficient. However, when you slow down PSC motors, their efficiency goes down as well. When you slow down an ECM motor, its efficiency stays the same. So the slower and the longer you run an ECM motor compared to a PSC motor, the larger the energy savings you will see. Now, the savings the customer sees are going to be dictated by how they currently use their system and how they are going to use their system after they install the Evergreen. We'll talk more about that now. The savings a customer sees using Evergreen are going to vary depending on how they use their system. If they are currently running constant fan and they install an Evergreen and continue to run constant fan, they are going to see a very large savings, up to 75%. However, if they are not currently running their fan, as many customers are not, because as we've discussed, it's noisy and costs a lot of money to run PSC motors continuously, if they install an Evergreen and then run their fan continuously, adding those 5,000 hours of motor operation, they may not see as large of a savings on an annual basis. They will most likely still see savings, but it won't be as high as 75%. So you have to evaluate how the consumer is currently using their system and how they're going to use an Evergreen system. But that's okay, because energy savings isn't the only benefit of Evergreen. You're still going to get better airflow performance, which is going to increase the capacity of the HVAC system. You're still going to get a very quiet constant fan, almost invisible. And with that constant fan, you're going to increase the usage and the effectiveness of the indoor air quality products in that home. So with Evergreen, you can upgrade to ECM today.